Hello and welcome to PTC's Demos and Tech Tips videos. This one-stop video library will help you learn more about PTC's solutions. Tech Tips provide methods developed by product experts and the technical insight to help you become more productive. With this demonstration, I will show you a quick example of creating a concept design of a fixture assembly using Co-Create's explicit modeling technology. Co-Create Modeling, the world's #1 explicit 3D CAD software system, is a complete environment for 3D product design, with a broad set of integrated design modules that add extra capabilities to meet your specialized needs. I am going to start with an existing legacy 2-view drawing. This drawing could have even come from another CAD system. I'm going to copy the 2D geometry and use it to define my 3D model. Notice the width of the part is 9 millimeters. I can reuse this drawing as it is to generate 3D geometry. By picking on the drawing, Co-Create Modeling recognizes the profile and uses the push-pull function to quickly create our first part, a bracket. Now I'm going to create another part called base in context with the first part. I don't remember the depth of the bracket, but that's okay, as I will just snap to that back face of the bracket. I now have two parts, the base and the bracket, and can add additional geometry to continue to create the base part. So I am sketching in context of these two parts. Notice how the cursor references other geometrical conditions, such as tangencies and center points, whether it is on existing 2D or 3D geometry. There is no need to constrain your sketches, and I don't need to keep my sketches typically. I will interact with the model and directly on the 3D geometry. Let's pull another piece of geometry out of this part, and then we can simply add some blends. In Co-Create Modeling, you can add blends anytime and in any order, and even across multiple parts as well. You don't have to go into some part editing mode or assembly modeling mode. You are just always in this virtual 3D space, where you can interact with geometry and parts synchronously and simultaneously. Organizing parts in Co-Create Modeling is as easy as dragging and dropping parts into assemblies, just like in Windows. I can create an assembly and drag these two parts and put them into that assembly. I designed or I created the parts in context, so I didn't have to position them. Now, let's take a look at direct modeling in particular. If I was to click on this end cylindrical face and move it, what do you think would happen? Well, with direct editing and Co-Create, it will recognize the tangent conditions and maintain those relationships. If I wanted to move all three of these cylindrical faces at the same time, I can box select and pull them, but notice the adjacent faces. The outer faces are updated based on the tangency relationship, but that interface is being extended, as would be the case with any direct edit type functionality. So to capture a little bit of design intent here, I'm going to just add some parallel relationships to these faces, so they will stay parallel with each other for this part. Now let's take a look and see how these relationships impact the intent of this part here. If I box select, let's just see if that parallelism is maintained, and you can see that it is. The base part is symmetrical, so I will use the reflect command to quickly create the other side of the bracket. Alright, so let's create another bracket. In this case, I'm going to share it. So actually, I'm not creating a new part, I'm just creating a quantity of 2 of these bracket parts. With co-create modeling, one part is not a parent or a child of the other. They are just 2 parts. I can modify any one of those parts, and the part is modified regardless of which part I was actually interacting with. I want to create a copy of the existing fixture assembly. I can just select the assembly, copy, and drag the new assembly into position. We want to create a control arm part that connects the 4 brackets together. We can create a new sketch off of this face and reference the 3D geometry of other parts. Right in the middle of this push-pull function, I can say I want a new part and give it a name. It is actually creating this part in the context of the assembly. I'll pull the profile to snap to the edge of the bracket, and there, we have our new part. I can bring back my profile to reuse some of the existing 2D data. Here, I only want the 2 circular profiles to be pulled to the width of the brackets. I'll reuse that profile one more time to create the cylindrical shafts on the far side of the control arm. As you can see, the pull command is automatically removing material because the profile is cutting through the part. We can easily change this to add material. Now, let's see how the linkage system works together as a unit. If I pull on the control arm part, you can see it just slides in place, not affecting the other parts. This is because we have not defined any relationships between the parts in the assembly. This time, I will use the physical simulation option. This function will calculate live how the parts would move in conjunction with each other as one unit with no relationships defined. However, the blue base parts rotate out of place, as they do not have a relationship telling them to stay stationary. We can create a quick relation set to fix these base parts in place. Now, when we rotate the bracket around its axis with physical and update relations turned on, we get a realistic representation of the 4-bar linkage and how it would work. So in just a few steps, we were able to quickly create some 3D geometry, validate the 3D geometry through a simulation of the mechanism. After analyzing our 4-bar concept design, I want to change the motion in our linkage system. I can do this by stretching out the length of one of our bracket arms. As you saw before, I can modify one of the arms, and both change because they are shared. Before I make the change, I'm going to add a couple of dimensions to the assembly. You can use these 3D labels in Co-Create to drive model changes just by clicking on the dimension. Where I pick on the dimension defines how the model is modified. Now I will modify the length of the arm to make it longer. I can also add in other faces from other parts into the modification of the arm part. Notice how the control arm part changes length as we are modifying the bracket parts. Let's take a look at how the linkage will work together with the new, longer bracket piece. With the longer bracket, you can see how we get a different motion with the parts. So in conclusion, I hope you were able to see the quick, fast, and ease of use for creating a concept design of this assembly in Co-Create modeling. Thank you for your time and attention. Thanks for watching PTC's Demos and Tech Tips. Work smarter, not harder.